Okay, welcome back. We are going to be looking at how to solve higher degree equations. That's what this means. Zeros. We'll talk about that in a minute. So we know how to solve a quadratic equation. We have the quadratic formula. We have the method of factoring. We have the method of completing the square. The best, though, of course, is the quadratic formula. But what do you do when instead of the exponent being 2, the exponent is 3 or 4 or even higher than that? Well, mathematicians could just throw their hands up and say, forget it, we can't do it. Or they could actually discover another way of doing it. And they have indeed. Now, first of all, from now on, we're not going to be calling the answers to an equation roots. You know, we've been calling them roots. From now on, we're going to be calling them zeros. So about 3 or 4 years ago, I actually said, why are they called zeros? So I went to the internet and I got two interpretations. One of them has to do with the fact that when you take the answer and substitute it in the equation, that it comes out to a zero. The other reason that I read was that if you were solving a quadratic equation, and you get the answers, and you wanted to graph the solution, that even though the value of x is -2 or 3, that all along this line, the x-axis, the value of y is equal to 0. That's another reason why they could be called zeros. But from now on, we call them zeros. That's the first thing. The second thing is, well, this is kind of a difficult equation to solve, but there's a couple of theorems that help us to solve this. One of them is called the fundamental theorem of algebra. You think, wow, pretty earth-shattering, right? The fundamental theorem of algebra. Oh, lightning strikes, The fundamental theorem of algebra states, and we don't have to write this, but just understand what it means. Whatever that number is up here, the lead exponent, whatever the lead exponent is, that's how many zeros there are going to be in an equation. So if it's a 3, that means there's going to be 3 answers. If there's a 4, 4 answers. If there's a 7, there'll be 7 answers. Some of them could repeat, but there's nonetheless 7 answers. That's very helpful because we know we have to look for 3 values of x to solve this equation. Okay, very good. Also, if the exponent well, let's put it another way. So you should never just write until after I've collected my thoughts. If the degree of the polynomial or the function is odd, and the degree simply means the highest exponent. So the degree of this polynomial is 3. If the degree is odd, that means that there will be at least one real and rational at the same time, real and rational 0. these are the basic, oh, there's one more concept. And related to this, and if so, then that zero will be in the form, let me sit down. That zero will be in the form which is equal to the factors of the constant. This number out there, this number out there, this number out there is always called the constant. Will be in the form of the factors of the constant. The factors of the constant divided by the factors of the lead coefficient. I'll translate all this into English for you in a moment. These are just some things I had to write. It's incumbent upon me, as your professor, to, give you all the information. And then to kind of narrow it down so that it all makes sense. So that's what I'm going to do right now. So first of all, this is why they're called zeros, because they're all on the x-axis where y is equal to 0. Okay? The fundamental theorem of algebra means that whatever that number is tells us how many zeros there are going to be. Remember when it was 2, there used to be two answers. When it's 3, that means there's going to be 3 answers. If the degree of the function is odd, as this one is, then there must be at least one real rational zero. And that real rational zero, not and if so, and if so, that zero will be in the form of the factors of the 5 divided by the factors of the 1. So therefore, if we look at this equation that I have on the board right now, that means that the following are the possible, the following are the possible rational zeros. Simply put, the answers. The answers are going to be the factors of 5, which can either be positive 5, negative 5. These are the only two factors of 5 you could have, or 1, positive 1, negative 1, right? These are the only possible factors of 5, 5 and 1, divided by the factors of x to the third, which would be positive 1, actually positive 1 or negative 1, negative 5 or positive 1, or actually negative 5 over negative 1, or positive 1 over positive 1, or positive 1 over negative 1. Basically put, let me make this simple. The following are the possible rational zeros, either positive 5, negative 5, positive 1, negative 1. These are the only 4 possible rational zeros that will be in this equation. Now, how do you determine which one it is? Well, you use synthetic division. This is the real benefit of synthetic division. So let's take this x to the third plus 9x squared plus 19x minus 5 equals 0. And the first thing, we just pick a number. Pick like -1. Let's see. If -1, so we're saying, we're taking a guess. We're saying we think that one of the possible rational zeros is going to be -1. Okay, so let's try it. If it works, it'll come out with no remainder. If it doesn't work, there will be a remainder and we'll have to try another one. So we go like this. Synthetic division, right? Remember that? 1, 9, 19, -5. And we're trying, the first one we're going to try is -1. So let's see what happens. -1 times 1, -1, 8, -8, 11, -11. Is this going to be a 0 here? No. Therefore, it can't possibly be -1. If it's a root or a 0 of this polynomial, then this number has to be 0. So this doesn't work. This doesn't work. So we try something else. We try 1, 9, 19, -5. Well, this one's not going to be it because we just tried it. Let's try +1. 1, 1, 10. Whoops. Too fast, you see. A little too fast there. Okay, 9 and 1 is 1 times 10 is 10. 29, no way. 29, that's not going to be it either. So it can't be +1. That's out. Okay. Sometimes, and I'm purposely doing it so that it doesn't come out, so quickly. So you have to do a little work. So let's try it again. And let's, we used 2 of them. Let's try the other 2. So 1, 9, 19, -5. And let's try the -5. -5, 4, -20, -1, -5 times -1, +5. Aha. See? 0 remainder. Therefore, this is one of the roots of the equation. So let me repeat what I just said. Let me repeat. Let's go back up a little bit. This was the equation that you were given. Your job is to figure out how to solve this equation. So what you do is you take all the possible rational zeros, and they're going to be the factors of 5 divided by the factors of 1, which basically boils down to either +5, -5, or +1, -1. Those are the only factors of 5, because everything over here is just going to be 1. Okay? And we tried 2 of them. We tried -1, didn't work because there was a remainder here. That doesn't work. This remainder. So that was out. We crossed it out. We then tried +1. We wound up with a remainder here. No good. So therefore, we crossed it out. Then we tried -5. We worked it out. And it wound up giving us a 0 remainder, which is exactly what we want, which means that -5 is one of the zeros of this equation. Now, what do we have left here? We have x squared plus 4x minus 1 equals 0. And the only problem there is that you can't factor this. So how do you solve a quadratic equation that cannot be factored? Tell me, tell us, tell everybody. How do you solve a quadratic equation that can't be factored?
Do we formula? Formula?
Oh, come on, folks. This is like, come on. Ever hear of the quadratic
Do
formula?
we use the formula, Professor?
Yes, yes, yes. A is 1, B is 4, C is -1, X equals negative B plus or minus the square root of B squared minus 4AC over 2A. Yeah, when a quadratic equation can't be factored, then you use the quadratic formula. Okay, so let's see what happens. X equals -4 plus or minus the square root of B squared, which is 4 squared, minus 4 times 1 times -1, divided by 2 times 1. Continuing up here. X equals -4 plus or minus the square root of 16 plus 4 divided by 2. X equals -4 plus or minus the square root of 20 over 2. And let's simplify this. There's a lot of simplification that could occur here. -4 plus or minus the square root of 4 times the square root of 5 divided by 2. X equals -4 plus or minus 2 times the square root of 5 over 2. Let's factor out a 2. We get -2 plus or minus the square root of 5 over 2. And the answer, you drop out those, the answer are, well, one of the zeros is -2 plus the square root of 5. One of them is -2 minus the square root of 5. And remember the original one that we found over here, the other root, because there's 3 altogether, because it's to the third power. It's to the third power. So that means there has to be 3 zeros, and here are the 3 zeros right here. So we solved this problem. That's how you solve the problem. It's a complicated problem. It's a third degree equation, and we want to figure out what the solutions are. And first we did it using this method with synthetic division. We got one of the answers. We suppressed the equation to look like this, and we used the quadratic formula to get the other 2 zeros. These are the 3 zeros. That's the end of the problem. That's the end of the problem. Does anybody have a question?
Professor,
Yeah.
I do understand it all, but can we go over
Do you
how
really?
we got
Do
the
you really
-5?
understand it? Are you just saying that to make me feel good?
No, no, I really do. But it's just this part that I want to make sure I get it, how we got the -5 and the -1 and that list of possible
Yeah,
solutions.
yeah. It's just, where is it? Where did it start? Up here. It's just all the factors of 5. What numbers go into 5? +5, +5. Don't look at these. Look at these right now. +5, -5, +1, -1. Those are the factors of 5. That's all I did.
Okay, so just the factors of the constant.
Well, divided by the factors of the lead coefficient, but the lead coefficient is 1. So, I mean, we could put a 1 under the 5 and a 1 under the -5 and a 1 under the 1, but it's just 1. So it's not going to change the value of anything. So I didn't even bother putting it in. It's just going to be 5, -5, +1, and -1. But yes,
Okay.
yes. Let's do another one. Let's do another one. Okay? So let me erase
How
the
do you
board.
get it if it's not 1?
I'm sorry?
How what would it be if it's not 1?
Oh, let's do that a little bit further down the road, okay?
Okay.
I don't want to do that. I don't want to do that now. Let's get some experience and then we'll do that, okay? Here's the next problem. Problem 2. So f of x equals x to the third plus 3x squared minus 6x minus 8. So what we're looking at first is we're looking at how to solve this equation. That's the goal. That's the goal. This is the function. This is the equation. Again, you'll notice that the lead coefficient is 1. And that's because we're just not ready quite yet to investigate what happens if it's 2 or 3. We'll do that. Don't worry. We'll do that. Okay. But the factors of 8. So what are the factors of 8? +8, -8. +4, -4. +2, -2. +1, -1. Get it? All the factors of 8. A little more difficult than the 5. The 5 only had 5 and 1. The 8 has, 8 times 1. It has 4 times 2. So you have to take all those numbers into account. And you may have to go through a little bit of work in order to figure it out, But let's take an example. Let me see what I have here. Good. All right, so let's just begin. Let's just begin. 1, 3, -6, -8. And let's use -2. I'm just picking a number. I'll let you pick the next number, but I'm picking -2. 1, -2, 1, -2, -8. Looks promising, but -2 times -8 is +16. No good. Because this has to be a 0, so that doesn't work. So you try another number. Give me something else. Just call something else out. Another number.
-4.
Okay, good. Good choice. 1, 3, -6, -8. And what'd you pick? -4? Okay. 1, -4, -1, +4, -2. Whoa, boy. Bingo. Good. Good choice.
Oh, wow.
Yeah, good. Let's make sure we got that, right? 1, -4, -4, -1, +4, -2, +8, 0 remainder. Beautiful. Very, very nice. So there's one of the possible zeros. See, it's trial and error, but you'll find out something very interesting in a few seconds. So what's left here? What's left is x squared minus x minus 2 equals 0. But very interesting, because unlike the previous problem, this can be factored. Sometimes they can be factored, and when they can, life is much easier. X and X, 2 and 1, negative and positive. See how important factoring. Remember factoring when we did that at the beginning? I think, I don't know, was it the beginning of the week? Or whatever it was, that, factoring is critical. Therefore, x plus 1 equals 0, x minus 2 equals 0, x equals negative 1, x equals positive 2. See, Fama, if you had chosen not negative 4, but positive 2, it would have worked. If you had chosen negative 1, it also would have worked. So any one of these would have worked. So 3 out of the possible, how many were there? 1, 2, 3, 4, 5, 6, 7, 8. There were 8 possibilities. So the odds are that 3 of them would have worked. And once we eliminated that one, it was 50-50. So you picked the right one. But if you had picked negative 1, it would have worked also. Positive 2 would have worked also. So the zeros, summarize it. The zeros are x equals negative 1, x equals positive 2, x equals negative 4. There's the answer. I don't think that was so bad. I mean, if it works out, it's like a lot easier than using the quadratic formula, right? That's that makes it a lot more difficult, but sometimes it does work out. Now, the only thing I'd like to show you is if these are the zeros, then the factors, the actual factors are x plus 1 times x minus 2 times x plus 4 equals 0. The actual, if these are the zeros or the roots, the factors are always the opposite sign. So you just make that positive 1, negative 2, positive 4. And this is called the linear factorization. The final exam asks this question. They want you to also not only find the zeros, but also create the linear factorization, which is not difficult. It's just, taking the roots and using the opposite sign. Taking the zeros and putting the opposite sign. So really, this is the answer to the question. And that's the complete problem from top to bottom. So f of x will equal x to the third plus 2x to the second minus 5x minus 6. Okay, I will give you some time. Let's see if you could do that. Let's begin. So step 1. Step 1. X to the third plus 2x to the second minus 5x minus 6 equals 0. The possible rational zeros so because it's an odd number, it's got to have at least one rational zero, and the possible rational zeros will be positive 6, negative 6, positive 3, negative 3, positive 2, negative 2, positive 1, negative 1. These are the possibilities. And, you just never know. But, you can start over here. Now, the class probably knows better than I do because you've done this. But if I were doing this problem I would disregard these two right off, right away. I wouldn't look at the 6 and the -6. I just wouldn't. I would just focus on these. And I mean, I don't know. Let's just try, I would try -3. So let's see, 1, 2, -5, -6. 1, -3, -1, +3, -2. I didn't want it to work out on the first try. I really didn't. 1, -3, -1, +3, -2, +6. I didn't want it to work out, but there it is, okay? So this is one of the zeros. Then we get this. Which can be factored, right? So this can be factored. Actually, it was the same one as the one before. It's weird. Practically, I think it's the same one. X equals -1, X equals 2. There's the two, there's the other two. So there's 3 altogether. So, but summarizing all of this, the zeros are X equals -3, X equals -1, X equals 2. Okay, those are the zeros. And actually, if I had picked -1, it would have worked. You see, if I had picked this one, it would have worked. If I had picked 2, it would have worked. But I picked -3 and it worked. But you know, the odds were 50-50 because I was eliminating the 6 and the -6. So the odds were 50-50 that it was going to work. So that's the zeros. And what I should also include is the linear factorization. Get used to doing this. The linear factorization will be, now remember, it's the opposite. So it's X plus 3, X plus 1, X minus 2 equals 0. This is the whole problem from beginning to end. And if you multiply all these binomials together, you would wind up with the original function. But we're not going to do that right now. I'm just assuming that since everything worked out, that it must be right. Okay?
Is that how you check to make sure it's correct?
Yes.
Okay.
Yes. If you wanted to make sure it was correct, that's what you would do. You would just take the linear factorization, multiply everything together, and if it came out up here, it's the right answer. But frankly, I never do that because, you know, this is so complicated, what we did, even though it went pretty smoothly, even, you know, it's still complicated, and it all worked out pretty well. It's got to be right. It just has to be. But again, if you want to, you know, multiply these 3 together, you should get the original function. Yes. Now, I have a dilemma. The dilemma is, do I do one with that comes out to a fraction? Let's go for it. This is a question that was actually on a final exam. So here's the question. If f of x equals 3x to the third, so there's the answer to your question. It doesn't always have to be minus 2x squared plus 48x minus 32. So if f of x equals that expression, well, that's a hard one. that 32 has a million factors, but they give you a hint. They tell you on the final exam, they say if f of x equals this, and the big and, one of the zeros is 2/3. They're giving you one of the answers. Find all the zeros. So, I mean, you want me to do this? Because it's a little different. I'd be happy to do it. I'm going to do it, okay? So the first thing they always do on the final is they want you to list all possible, I mean, this is a guaranteed question on the final. You know, it's a 10-point question on the final. So, you know, that's a question you should think about. And the question on the test that you're going to be seeing won't be this difficult. It'll be like more like these, but this is a final exam type question. All possible rational zeros. All possible rational zeros. And, you know, there are a lot of them because it's all the factors of 32. It's 32 over, well, let's not do over 1. Let's not do the ones. Well, we need to do the ones. We need to do the ones. 32 over 1. 32 over -1. This is a ridiculous thing. Look at this. Negative 32 over 1. Negative 32 over -1. Negative 8 over 1. Negative 8 over -1. Positive 8 over 1. Negative 8 over -1. See what's going on? Now, you know, it's going to overlap in many cases. So -8 over -1 is the same thing as +8 over +1. So there's like an overlap. But this is what the final exam asks for. So +4 over 1. +4 over -1. -4 over 1. -4 over -1. 2, right? +2 over +1. +2 over -1. I never liked this part of the test that much because it's an onerous process that takes up time. And then +1 over -1 and +1 over -1. And then look at this. It's unbelievable. -1 over +1, and it goes on and on. And then when you get to to this one, you have to take into account the threes. So it could be 32 over 3, and all of that. 32 over 3, 8 over 3, 4 over 3, 2 over 3. Well, you keep going until you get there's like a million of them. It's crazy. It's a crazy problem. But, the final exam tries to make it as complicated as possible. But they're giving you a hint. So after you've done all this stuff and used up all your energy on that, they tell you that this is definitely one of the zeros. So let's prove that it is. The synthetic division, right? 3, -2, 48, -32, and 2/3. All right, so they're telling you that this is probably, I mean, if they're giving it to you, that means that it's going to work, but you have to show it. So you need to be able to take 2/3 of 3. You need to be able to multiply 2/3 times 3, which equals 2. So 3 times 2/3 is 2. This is 0. That's helpful. 2/3 of 0 is 0. That's 48. 2/3 of 48. 2/3 times 48 is 32. There it is. You see, you've proved it. So the answer to the first part of this question is yes, 2/3 is one of the possible zeros. And then you're down here now, which is 3x squared. No x, right? Plus 48 equals 0. Now, what do you think you do next? Anybody know what to do next?
Professor, can you please repeat the question? What was
Well,
your question?
my question is, here I am. What do I do now?
We can factor it by
Okay.
3.
Well, I would take out a 3. I would take out x squared, and look how much simpler it becomes. And then divide by 3. You see the 3's drop out, and you get x squared plus 16 equals 0. Bring over the 16. X squared equals negative 16. X equals plus or minus the square root of negative 16. All right, so let's, x equals positive the square root of negative 16, and x equals negative the square root of negative 16. X equals positive I. Remember the I? You take out the -1, that leaves you with a perfect square, because x equals I times 4, 4i. X equals negative 4i. There are the 3 roots. There are the 3 zeros. The 3 zeros are 4i, negative 4i, and of course, 2/3. That's the answers. They leave you with this weird thing, but it's easy to solve. It's easy to solve. And you wind up with 4i, negative 4i, and 2/3. And you could even do the linear factorization, x minus 4i, x plus 4i, and x minus 2/3 equals 0.